Hey everyone! In today's video, we're going to be taking a quick look at the Qotom Q750G5 mini PC, and we'll spend a little bit of time both looking at the hardware, installing OPNsense, as well as running through a quick set of performance testing to see what this box is capable of. Now, I decided to pick this up recently because I'm currently using a Meraki MX64 firewall, which has run well for the past couple of years, but unfortunately that firewall is limited to 250 megabit of throughput, and I wanted to upgrade my internet speed recently, mostly in order to get some better upload speeds, but if I was going to do that, I needed to upgrade firewalls. And so ideally I wanted to buy something that had enough power to maybe at least hit gigabit speeds, if not maybe a little bit more, but I actually stumbled across this Qotom box, which has 5 2.5 gigabit Ethernet interfaces, and surprisingly, the hardware inside can keep up with those speeds. Hopefully by buying this box, I'll have quite a bit of runway to go into the future, depending on how much I decide to upgrade my internet speeds over the next couple of years. So that being said, let's just go ahead and quickly take a look at the hardware itself. So surprisingly enough, this firewall came in a very plain box without much information at all about what it is, no branding or information or anything like that. If we go ahead and open it up, we'll see quite a handful of different components. First of which being the power cord and power brick, which is going to be pretty standard. This also does come with a bunch of other ancillary additional screws and standoffs in case we need them, as well as a bunch of those little rubber feet to put on the bottom of it in case you decide to set it on a shelf or something like that. And before we take a look at the unit itself, right underneath is a mounting bracket. So if you did want to mount this to something like a TV or monitor or something else, that bracket is included by default. Now, the first thing I noticed about this device pulling out of the box is it is actually surprisingly heavy. The casing itself is solid metal, there's not much plastic involved, so this tiny box, even for as small as it is, has quite a bit of weight to it. So pulling it out of the wrapping real quick, the first thing you might notice is that the case has kind of a heatsink looking design, which is for a reason, which we'll get to in a little bit. So we'll take a look at the front of the unit first, which has a couple of things you wouldn't be surprised by, like a power button and a reset button, as well as hard drive and status lights. Because it is a mini PC and it could be used for something other than installing an embedded firewall system, we do have an HDMI port, as well as 4 USB ports on the front. Next, we'll go ahead and flip it around to the back. And on the back, we do have those 5 2.5 gig Ethernet ports, as well as the power port. Optionally, this model can come with embedded Wi-Fi included, so there are 2 slots on either side for the wireless antenna. Because I bought a model that did not include Wi-Fi, I kind of wish that the casing came with some sort of stoppers or covers for the wireless antenna holes, but overall it's not that big of a deal, and so, it is what it is. So let's go ahead and take this thing apart a little bit. So we'll go ahead and pop off the bottom casing. Now, interestingly enough, I did find when I was disassembling this the first time that the bottom casing, even after you remove all of the screws, is actually held in pretty tight by both the front and back panels. It seems like they're screwed on tight enough that they're also wedging that back panel on tight enough. So I ended up having to loosen one of the side panels as well just to be able to get that bottom panel off. Okay, once that panel is removed, we'll have quite a compact little motherboard that carries a lot of power to it. So we'll zoom in just a little bit so that we can get some of the detail here. Now, buying these direct from Qotom, you could buy them in a number of different configurations. I opted to go with a 256 gig hard drive and 16 gig of RAM, which is probably a little bit overkill for loading an OPNsense box, but I was shocked to see that I could buy all of this and the device itself shipped to me for just barely over $200, so I decided to just go ahead and go with the beefier components in case I ever needed them. So one thing you might notice as we open up the box is that in addition to the M2 SSD, we also do have a SATA cable that's just bouncing around in there. This is in case you wanted to install another like 2.5-inch hard drive. If you were to install one of these drives, the bottom panel of the device does have mounting holes for that drive to stick to, so it's not just bouncing around inside. So we'll go ahead and move that off to the side for the moment and take a look at what else we have here. So like I said, I did get 16 gig of RAM. This did come with a 16 gig DDR4 stick from Team Group. On the SSD side, we'll have one screw to remove to get that out of the device. And this is just a WHO disk, 256 gig SSD. Now, part of the reason that I took those out of the box is because there are a couple of components that are hidden by those items. So under the RAM stick, we can see the BIOS battery, and we have a couple of additional slots to check out as well. So in the upper right corner, we have a PCI slot for Wi-Fi card. But interestingly enough, in the bottom left corner, we have a combo slot that says it is for 3G or Wi-Fi. So you could, in theory, load cellular. And in fact, just underneath where our SSD was located, there is a cellular SIM card slot. This isn't something that I'm interested in since I actually have a separate 4G LTE modem that I use for backup internet, but that's a separate device, so it's not something that I'm necessarily interested in compiling into this box. One thing I was really interested in by opening this up was I didn't immediately see where the processor was. And so I had my suspicions, and maybe for some of you who run some of these mini PCs, you've already guessed where it's at. But for me, it was really interesting to see how this was built and where they hid that at. So in order to find it, we're going to have to take off either the front or back panel. So I've flipped over the device and I'm removing the back panel of the device here. And once we get that back panel taken off, it's a little bit difficult to see, but you'll notice that right in between the motherboard and the top casing is where the processor is located. And sure enough, that processor does have thermal paste attached, and it is connected directly to the external casing of the mini PC to use it as an actual heatsink. So it seems like a pretty nice and efficient use of real estate inside this tiny box. One thing I will call out on that is that in my testing and running it, there's been a couple of times where I've had the CPU pegged at 100% for 10, 15, 20 minutes or longer, and this box does get hot. So especially on that upper right corner of the top right there where that processor is located, the box does get really, really toasty. So you'll want to make sure that if you're running this, that you don't have anything sitting on top of that for long periods of time. And also it might be worth just being a little bit careful if you ever decide to, touch the box if it's running kind of hot. So with all that being said, we'll go ahead and go in reverse order and reassemble this by putting back in the hard drive and then the RAM. Once those are back in, we will reattach the bottom side of the casing. Okay, now that we're done taking a look at the physical hardware itself, we're going to jump over to installing OPNsense, which is what I'm going to be using for home firewall software from here on out. And so we'll go to the OPNsense website at opensense.org, and we'll just go ahead and click the big orange button to download OPNsense. We won't change any of the settings, but I will go ahead and pop open mirror location and find something relatively close to me in the United States, and then click the download button. That will download pretty quickly, and in the meantime, I will grab the SHA-256 hash of the image so that we can validate it before we burn this onto a USB drive. Once the image is downloaded, I will go ahead and validate the hash. I use an extension in Windows called HashTab, which will add this hashing utility right into the Windows File Explorer. So you right-click Properties, open it up, and you'll auto-generate the file hashes. It looks like the hashes did match, so everything is good, and we can go ahead and move on to loading this onto a USB drive. So first thing we'll need to do is we will extract the image file out of the zip that we downloaded. And now that we have that opensense.img image file, we can just go ahead and open up Rufus, which we'll use to copy this to a USB drive. Once we're in here, I have a 4 gig USB drive that I'll be using. We'll go ahead and select the ISO and then just go ahead and hit start. Once that's done loading, we're ready to go over to the device itself and install OPNsense. So funny enough, even though I bought this device that was supposed to be bare bones, no operating system or anything like that loaded, the first time I loaded this up, it actually booted into a full licensed copy of Windows 11, which I thought was a little bit strange. So in theory, like I was saying earlier, you could use this mini PC not as a firewall or router, but you could use it as an actual embedded PC if you wanted to. But in my case, I did want to use this as a firewall, so I'm going to go ahead and load OPNsense. So I popped in the USB drive and booted up the unit. And initially, what'll happen is OPNsense will actually boot into a live mode. And what this means is that it's running off of the USB drive. So if you wanted to test out OPNsense, make sure it worked with all of your hardware, test out some of the features and play with it without actually installing it on the device, you could do this in that live mode. If you were to reboot the device and remove the USB drive and restart the system, it wouldn't leave any lasting installation or changes. So for example, since this did boot up Windows on my first boot, if I ran this just in live mode, tested, played with it and all that stuff, and then removed the USB drive and rebooted, it would boot back into Windows with no problem. So that being said, once this boots up in live mode, what we'll need to do is log in with the installer account to actually start the install onto the hard disk. So I'll do that using the login, installer, and the password OPNsense, and that will go ahead and start the installer interface. And so first I'll just go ahead and hit next here. I will be using ZFS as my file system, so I'll go ahead and click on Install ZFS. Since I only have one hard drive installed in this machine, there's no sense in configuring any sort of RAID or anything like that, so I will leave it on Stripe, which means there's no redundancy. And I will select that HDisk SSD as the target for installation, and go ahead and hit yes. And then we'll let this go for a minute to go ahead and install the operating system. Now, before we wrap up the install, we are prompted to reset the root password if we want to. I'll go ahead and do that real quick. Once that's done, we'll click Complete Install. Next, the device will reboot into the full installed copy of OPNsense. Once the device finishes rebooting, we'll be dropped into that same login prompt that we saw earlier with the live image, except this time everything is installed on the SSD that's inside the box. Now we could log in here with our root account and walk through a nice little command line system in order to do some configuration changes like interface IP addresses and stuff like that. Or we could just connect to the box directly and open up the web interface. Now the one thing I'll call out here is that you can see it shows both our LAN and WAN interfaces are configured by default. LAN is set to IGC0, which is going to be the first interface on the tiny PC. And it currently has an IP address of 192.168.1.1, and that interface is running DHCP. So what I'll do is I will take my PC and just plug in an Ethernet cable directly from my PC to that LAN interface, and my PC will receive an IP address from that LAN interface on that subnet, and we can go ahead and move through the configuration in the web interface. So before we jump into some of the configuration and performance testing, I did want to bring up a quick little topology diagram to demonstrate what I'm going to be configuring and setting up and testing here. So I currently have two Intel Nuke 11 mini PCs, which I did a video on a couple months back. Now those boxes both come with a 2.5 gig Ethernet interface built into them. So those are my best candidate for running performance tests against this Qotom box that also has 2.5 gig Ethernet interfaces. And so both of those Intel nukes right now are running VMware. So what I did was I installed a Debian Linux virtual machine on either one of those ESX hosts. I configured PCI pass-through to allow that 2.5 gig Ethernet interface to pass through directly to the VM as if it was directly connected. Then we're going to have one of those VMs on the WAN side interface of the OPNsense box, the other one on the LAN side of the OPNsense box. And so both of those Debian virtual machines are running iPerf 3, which we'll be using for our performance testing. I will go through kind of a typical setup that you might expect, where the LAN side is NATed out to the internet on the WAN side. We'll go ahead and set up some port forwarding and all that fun stuff so that I can reach the iPerf systems on either side of it. And after some initial tests, we'll also run through what performance looks like with intrusion prevention enabled, as well as some VPN performance using Wireguard. And so with that, first we'll just go ahead and hop over to the web UI and start doing the initial setup. And so I'll log in with the root account that I had created, and we'll be brought to the initial setup wizard first. And we'll go ahead and hit next. So first we'll be asked to configure some basic stuff like hostname, which I'll set to 0x OPNsense. For domain, I will be setting this to 0x2142.local. I will configure my primary and secondary DNS servers here. I will also uncheck the box for override DNS because that is not a setting that I want. I'm also going to uncheck the setting for unbound DNS because I do not want that running. Next, we'll be asked to provide time zone information. So I will go ahead and select mine here, and then we'll hit next. So on the WAN side interface, we're going to change the IPv4 config type to static, since I'm manually configuring an IP address on this interface. Then I'll configure the IP that I have assigned, which is 203.0.113.25, and that's a /24. We'll scroll all the way down to the bottom, and one thing I will uncheck before we move on is the block bogon networks. Now, the reason that I need to do this is that because the IP address that I'm using on the WAN interface is a reserved IP address that is non-routable on the internet, that is used for lab and testing and all that fun stuff. So by default, this is actually a setting that you would probably want enabled on your WAN interface. But because I'm doing this in a lab and I am using a reserved IP address range for this testing, I need to unset this setting, otherwise OPNsense will block all traffic from this subnet. Once we're done with that, we will go ahead and click Next. Now we'll have to configure the LAN side interface, and again, by default, it is that 192.168.1.1, and I will set this to 10.2.2.2 instead. We're prompted to set a root password if we want. Since I already configured one in the installer, we'll just go ahead and leave this blank and hit Next. Last but not least, we will be prompted to reload the system. Now in this case, because I am directly connected to that LAN interface, which was 192.168.1.1, but is now 10.2.2.2, I did also need to reconfigure the Ethernet interface on my local PC and reconnect to the OPNsense box. This time, once we log in, we won't be prompted to do the wizard. Instead, we'll be dropped right on the dashboard, where we get all sorts of fun information. For example, we get the information about what version our machine is running, quick stats on CPU usage, memory usage, disk space. One thing that I want to point out while we're still on this screen is just double checking a couple of things. If we look down below too, we can also double check that on our memory usage that we do see that full 16 gig, as well as disk usage, we're seeing about 223 gig, which is close enough for the 250. So it looks like everything's being recognized and utilized appropriately. So the first thing that we're going to do is we're going to go over and configure interfaces. Now, if you've not used OPNsense before, you might have noticed when I booted up the unit that it only showed two interfaces, one LAN interface and one WAN interface. But the machine that I'm using has 5 Ethernet interfaces. So what we'll have to do first is we'll go over to the Assignments tab under Interfaces, and we can add a new interface. So by default, the additional ports on the tiny device will not be assigned to anything. Since I'm using this only for performance testing, what I will be doing is creating another interface for out-of-band management. So this is going to be so that those Debian virtual machines that I have are going to be directly connected to the LAN interface and the WAN interface. Then I will still be able to access the web interface over that management interface. And so I'll just go ahead and set IGCO2 to a management interface and click Add, and then we'll hit Save. Next, we'll go up to that management interface. I will go ahead and click Enable Interface, set the IPv4 configuration type to static IPv4, and then all the way at the bottom, I will set that IP address for that out-of-band management interface. Once we're done with that, we will click Save and Apply, and then I'll go ahead and swap my connection over to that management interface. So next, I did want to set a virtual IP address out on the WAN side of the device for our NAT to the internal client. So I'll go ahead and set this to mode Proxy-ARP, interface to WAN, type to single address, and the dedicated address that I'm going to be using for the performance testing is 203.0.113.25, and we'll hit Save and then Apply. Next, we're going to go ahead and configure the network address translation. So we'll go down to Firewall, then to NAT, And the first thing we will set up is port forwarding. So this is going to be permitting any sort of traffic from the WAN side interface into an internal host. And so I will leave the interface at WAN, the protocol as TCP. For destination, I will set it to that virtual IP address that we configured earlier, the 203.0.113.25. And for destination port range, I'm going to scroll all the way up to the top and click Other. And we're going to set this to 5201, which is the default port for iPerf. Any traffic being sent to that IP address on that port, we're going to want to forward to 10.2.2.1, which is my Debian virtual machine on the LAN side interface. Then we'll go down and click Save and Apply Changes. Now, normally you might need to create a firewall rule to also permit this traffic coming into that WAN side interface. But by default, unless you change the setting, OPNsense will automatically configure a firewall rule linked to the NAT rule. So once we created that NAT rule, if we jump down to Rules WAN, there is a firewall rule already configured that will permit traffic from outside of the firewall on that WAN interface to our internal host over port 5201. Now, as we get ready for our performance testing, one thing that you can do real easily on the OPNsense box is go up to reporting and then down to traffic, and you'll see real-time graphs of the traffic coming in and out of the box. Up in the upper right corner, you can select which interfaces we want to show on the graphs, so I will go ahead and make sure that both LAN and WAN are configured here. Next, we're going to jump over to the two Debian virtual machines that I have. So on the right side, I have the LAN side iPerf server, and we'll check the Ethernet interface configuration, which does have that 10.2.2.1 address. And on the left side, we have the WAN side iPerf client, which is configured for 203.0.113.50, which matches our topology diagram that I showed earlier on in the video. So with that being said, on the server side, we will start the iPerf server with the command iperf3-s. Once that's running, on the WAN side, we can connect to that using iperf3-c for client, and we're going to specify the address that we want to connect to, which is 203.0.113.25. I will do -P8, which is going to make 8 parallel threads to run, as well as -T, which I'll set to 600, which is how long this test will run for, which is 600 seconds or 10 minutes. So now I wasn't really sure what to expect with this box by default. I wasn't sure that such a low power box would be able to keep up very easily with the 2.5 gig interfaces, but to my surprise, it had no problem. I was able to easily get that 2.5 gig speeds out of those interfaces without much trouble at all. And on the OPNsense side, it is just a plain install with just the configuration that I've shown in the video so far. There isn't any other tuning or any other magic going on there. So after that 10-minute test, it does look like our average speed throughout the test was 2.35 gigabits per second, which for me I think is actually pretty good. Next, what we'll do is we're going to move on to trying to determine speed tests while the Suricata intrusion prevention system is enabled. So we'll jump down to Services, Intrusion Detection, and I will go ahead and enable this and set it to IPS mode. Then we'll click Apply. Next, we'll jump over to the Download tab. Now, typically, you're not going to want to enable every single IPS or IDS rule that's available to you. You'll only want to apply the rules that make sense for your environment. But since we're doing this in a lab test and I kind of want to see what the performance is, I'm just going to go ahead and check all of them and enable selected. So we're going to enable every single rule on the box. And then at the bottom, I will click Download and Update to make sure that we have all of those rules loaded in. Then we'll jump over to the policy section and I will create a new policy. And I will select all of the rule sets that we have enabled. And for action, I will make sure that it is set to alert and drop. With that done, we'll scroll down to the bottom and I'll go ahead and set a description of test IPS and then save. And then we'll apply that policy. So we'll go ahead and jump back over to our iPerf machines. Now, I was really surprised to see that even with the IPS loaded and all of the rule sets enabled, we were able to easily get that 2.3 to 2.4 gigabit per second speed through the device. Now, I will say one difference as opposed to some of the earlier tests that I ran is that if I run over to the dashboard real quick, we can see that the CPU usage is actually much, much higher than it was earlier. And during a lot of my testing, it averaged between about 60 to 70 or 80%, which ran a bit high. One other thing that I wanted to call out with the IPS testing was that I did see a little bit of mixed results when I ran multiple tests. It seemed like once every rare while, when I ran an IPS test, one of the connections would get stuck or pinned to the wrong CPU core or something, and performance would just be absolutely terrible. On the best tests, I was easily able to get that 2.35 gigabit. On some of the worst tests, I got somewhere between 200 to 400 megabit, which is a huge difference. It seemed like anytime this happened, if I just went to OPNsense, restarted the Suricata service, everything would come back to normal. So again, I don't know if there's something under the hood getting caught, or if traffic's just getting pinned to the wrong CPU core, which I've seen happen with other systems before. Something was just pulling down the throughput to... This is a problem which I thought was kind of interesting, so maybe if I have some more time later on, I might try to dig into a little bit further to try to see exactly what was causing that. But for now, I kind of treated that as an anomaly since probably 80 to 90% of my tests got the full interface speed. Next, we're going to go ahead and jump over to VPN throughput. Now, there's a couple of different VPN methods that are offered by OPNsense. So by default, it comes with IPsec and OpenVPN loaded. But I really wanted to try out Wireguard, and I think this is what I'm going to be using for my home VPN from here on out. So I went ahead and loaded Wireguard on here, did the pre-config already. I may do another video later on setting this up and getting it all configured. So if that's something that might be interesting to you, please let me know. So for the first Wireguard performance test, what we're going to be doing is just testing the VPN throughput itself. So I did turn the Suricata IPS off. Now in this case, we are going to have 2 clients and 2 servers for a reason I'll get to in a minute. So I went ahead and created additional firewall and NAT rules to allow an additional iPerf port to come through, but we'll stand up one of the servers running on port 5201. The second server I will start up on port 5202. And so to start with, we'll go ahead and connect both of the client-side systems to Wireguard using the WG quick up command. Then with both of those, we'll use the Wireguard command to double check that we are connected. We'll also send a ping to that 10.2.2.1 directly, which demonstrates that we are traversing that VPN tunnel and we're able to pass traffic directly to the LAN side interface without having to go through that WAN NAT. With that being said, for the first client, we'll go ahead and do our same iPerf test that we were doing earlier, but we'll do it directly to the internal IP address, so we make sure we're going over that VPN tunnel. And I will specify the port number as 5201. Now with that single client running, we're able to get 500 to 550 megabit per second throughput over the Wireguard VPN. But what I found out was that because we're doing now encryption on the client side and decryption on the OPNsense side, since my client VM is doing both the encryption and generating a bunch of traffic on iPerf, and it doesn't seem like all of those things are multi-threading super well, I found that it was real easy for my VM to peg out one CPU at 100% with all of that stuff that it's trying to do, and it felt like that was limiting the throughput of Wireguard, which if we jump to the dashboard of OPNsense, it looks like the CPU usage is hovering around 80%, so there's definitely some wiggle room there to get some additional throughput. So that's where I decided to spin up a second iPerf client to make sure that we could try to get the true speed test of what the limit of encrypt-decrypt traffic on Wireguard was. So on my second box, I will go ahead and set up another client to the same IP address of 10.2.2.1, but this time using that second server port of 5202. And we can see real quick that between those 2 clients, we're now averaging a total of about 800 megabit per second. So I would say I'd feel more comfortable that that 800 megabit per second is probably about the limitation of what we're hitting for VPN performance on the Qotom box. And again, if we check the dashboard real quick, we can now see that it is slammed at 100% CPU from just decrypting all of that VPN traffic. Now, last but not least, as a final test, we're going to go back to the Suricata IPS, re-enable both the service and IPS mode, hit apply, and then we're going to go back to running those tests again. So now in this case, the client is generating and encrypting the traffic. The OPNsense box is decrypting that traffic, then running it through the Suricata IPS before passing it on to the LAN side client. So there's additional steps here, more CPU usage. We should expect lower throughput than we did with just the VPN performance. And sure enough, we do see a little bit lower performance. So with the single client again, before we were averaging about 500 to 550 megabit, now we're only seeing about 450-ish, maybe a little bit more. And the CPU on the OPNsense box is definitely higher. We're seeing somewhere between like 90 to 100% already. But that being said, wouldn't be fair if we didn't run it with both clients just to test. So we'll go ahead and spin up that second client as well to see if we can squeeze any more throughput out of this. And now between the two clients, we are squeezing just a little bit more throughput out of the OPNsense box. And we're seeing somewhere around 650 to 700 meg average, a couple times spiking a little bit higher than that. So it does look like we're losing a little bit of throughput with both the IPS and VPN enabled, but from my perspective, not enough to be concerned about. For most of my home usage, this is going to be way more than enough for what I need to do. Okay, with all the performance testing completed, I have to say I was honestly very, very surprised to see how much performance I got out of this tiny little mini PC, considering I spent barely $200 on it. The fact that I can get 2.5 gig speeds out of this, even with most of those services enabled, was not at all what I expected. So hopefully this little box should last me quite a while into the future. I'm considering doing some additional content and videos maybe on different configuration of OPNsense. I've already spent a lot of time over the past couple of weeks getting familiarized with it and configuring it and testing out all sorts of different features and functionality and all that stuff. So if there's anything specific that you'd be interested in seeing, like a how-to or something like that, please let me know in the comments. And as always, I hope that this video was helpful to you, and thank you so much for watching.